Okay, welcome ladies and gentlemen to the second half of section 8.1, dealing with what we call the ambiguous case for the law of sines. And this is the case where you have SSA on your triangle, or the given pieces are two sides and the non-included angles. So something along this line, if you had a triangle here and you said that this is 3 and this is 7 and this is let's say call it 60. This would be the SSA version, and there's some ambiguity here. That's why it's called the ambiguous case, meaning it might not actually even be a triangle. The given information might not be enough information to actually write a triangle. So let's see what this is going to look like. So for the SSA version, if you are given this information, you can either get no triangle exists. Everybody likes that problem because once you figure out there is no triangle, there's nothing left to solve. You could get the fact that one single triangle exists, or the one that nobody likes for some reason is the fact that two triangles might exist from the things given. And one of the cases would look something along this line. Let's say we were just given this. It might not exactly look just right for you here. I have to undo that really quick. I'm going to try to draw this a little bit better here. Let's say we were given something like this. Whatever this side is, this is X and this is A. Whatever, it doesn't really matter. But what I'm trying to get at is this particular side X, and if you were given this side A, or not this side A, sorry, this is A over here, my fault. This is A over here. We could, if this X is the right length, and if this A is a very certain length, this side doesn't only have to be here. By the way, you would be given this angle. This side could, if you think about picking it up and swinging the bottom out here, it could create this triangle right here where this side length is X. Which means we could have this big triangle in green, or we could have this littler triangle where it's got this red side in green here with the A, the X, and this angle. Now, it's hard to visualize if you're not a very visual person. And what you can do is you can create some little scraps of paper that are certain lengths and just rotate them around and show that there are actually two triangles that you could create. And all of these three things actually depend on the sizes of the given pieces. So remember, you're given two sides and an angle. So depending on what you're given, it will determine if you have no triangles, or if you have one triangle, or if you have two. So this is an or statement. It's one of these three things. And you can't have all three of those things. That doesn't make any sense, to have two triangles but have no triangles. Okay. So what we're going to pay attention to here, if you have any triangle, if you have some angle on this side or this side, but what I'm getting at here is this angle here. If you want to find the height of that triangle, this being the height, you would say this is little b. So if you had this triangle right here, it would be b sine of a. All right? The reason we need to know that is because the height is actually one of the key things that help us determine what we get. Now, if you don't write anything else from the notes today, this thing that comes up on this page is the most important thing that you should write. If I see people without this written on their notes, that means you didn't actually listen to the notes. This is a table of what could happen. So what I first want to point out is if the given angle, so I don't care if this is A or B or C, it just says if the angle that you're given is acute, meaning less than 90, obviously, there are 4 possibilities. However, if the angle is obtuse, there are only 2 different possibilities. Now, when you are looking at a problem, and let's say A is 30 degrees, A is acute. All right, so it's going to be one of these 4 choices. Then I look at the next line in whatever box you ended up in. The next line says, okay, so here in this case, if A is less than the height. Well, if this is little a, that kind of makes sense. If little a is shorter than the height, it will never reach the base of your triangle. That's why there's no possible triangles that can be done. Okay, but what if a is not less than h? Okay, well then you go to this one. What if a equals h? If a equals h, that makes sense because a could just be the height of your triangle, and it actually makes one triangle possible. But not only that, it makes the fact that it's a right triangle. So this is kind of an interesting one. It makes a right triangle if a is acute and a is equal to the height. Then you come over here. Okay, what if a wasn't equal to h? What if A was bigger than B? So if A is the side opposite and B is this side here, and A is longer than B, then there's only one triangle that is possible for these pictures. And then this one, this is the one that nobody likes. This is the one like I gave the example on the last page. If A is acute, and the side A, the length of side A is between the length of the height and the length of B, then there are 2 possible triangles. Now I do have an example for this, so we will solve one of these. Then you come over here, if A is obtuse, then you make your comparisons and figure out if there's no triangles or just one triangle possible. Okay? What you'll notice whenever I draw these pictures, I always draw it this way. I always say this angle is the given side, and then this is the connecting side. So this is like the adjacent side. This would be my B, and then of course I would have my opposite side, which was opposite here. Okay, don't be confused. This is not hypotenuse. But this would be the side that's connecting and this side opposite. So even if they gave you C's and B's, let's say they said C is 30 degrees, little c is 10, and little a is 6. I would draw my triangle, like this. I would say, okay, A is 6. Actually, I might say my angle C is 30. I would say across is 10, and the connecting side is 6. I drew it this way because then the orientation is always the same for every triangle that I draw. So I don't get confused when I'm talking about, oh, is A acute? Well, I'm actually talking about C now, the given angle. All right, so let's look at a couple examples. That's what you guys are all here for. So first of all, we're going to determine the number of triangles and we're going to solve it. So hopefully you have that table in front of you. And I'm giving us a statement like this. Now you'll notice that I'm just going to draw a triangle because I know I'm trying to solve some sort of triangle. I don't even care what it looks like. And then I'm going to say, okay, since the given angle is A, I'm going to call this angle A. So this is 26.3. The side opposite is 7, and the other side given is 6. So notice I drew this direction. So this is little b, that means this is big B, this is big C, little c. So the question now is, how many triangles are there? Now, just because I drew this triangle doesn't mean it's the only one there, and it doesn't even mean that this is a triangle that can be drawn. So I have to do some checking. Let's find h. H is b times the sine of a. Well, luckily they gave you a and b here. So we're looking at h equals 6 times the sine of 26.3. You do this calculation really quick. And we go 6 sine of 26.3. And I get 5.52-ish. Okay? Then I need to look at my table. I know A is acute, so this is an acute angle. And I look first at my first piece of the table. Is A less than H? Well, H is 5.5, A is 7, so no. That means there's at least one triangle because that was my none. Does A equal H? No. Okay, so that means there's not one triangle, or that particular case is not there. So does A equal H? No. Is A bigger than B? Yes. So as I made a statement here, there's one triangle because A is bigger than B. Now, the whole idea is to solve the triangle. Well, guess how you solve the triangle? And if you said, I hope I heard everybody say, it's the law of sines. Because it's still the law of sines. Even though it's this ambiguous case, it's still the law of sines. So I would say that the, however you wanted to do it, I guess, sine of 26.3 is equal to 7, or sorry, over 7 is equal to the sine of big B over 6. And you can solve for angle B, then you can solve for angle C, and then you can obviously solve for side C. Now, I think we've had a lot of practice in solving these triangles, so I'm going to kind of leave it at that to try to shorten the length of the video for this particular problem. Okay, so this is a one triangle problem, all figured out from that table of values. So let's take a look at a different example. Now again, I have a triangle, and again, this particular case, I gave you A, B, and C, but don't think the textbook is that, or sorry, it gives you A and B. Don't think the textbook is always that generous. So I write my given angle over here. I give its opposite side here, and the other side there. That means this is big B, big C, little c. Now, oh, I could try thinking what I did earlier. Is A bigger than B? Oh, no, it's not because I use the same numbers, but I switched them around. Is A bigger than H? Or sorry, not bigger than, less than. H. I don't know because I don't find H yet. H is 7 times the sine of 30. Well, I know sine of 30 is 1/2, so this is 3.5. 7 over 2. Is A less than H? No. Because 3.5 is not less than, or sorry, 6 is not less than 3.5. Is A bigger than B? No. Does A less than H? No. Is A bigger than H? Sorry. Be helpful if I wrote things down correctly. Is A equal to H? No. Dang. Is H less than A less than B? Well, let's figure that out. It's easier if we had numbers. 3.5 less than 6 less than 7. Yes. And if that statement is true, then you get two triangles. Oh, that means we have to figure out what the two triangles are. So what I'm going to do is I'm going to erase this and I'm going to try to draw two triangles. So we already have the one that was given to begin with. And then the question is, what's our other triangle going to look like? This is the hard problem. But guess what? I still have to have this 7, and I still have to have this angle equal to 30. So this angle still has to be 30, and this side length still has to be 7. But that's the only thing that needs to stay the same other than this 6, which means this 6, as I was saying, it could be here, but I'm going to swing it around, and it's going to be right here. Okay, so that means I'm going to shorten my other line there to this, which means this is 6 now. Now, this is going to be the one you guys should pay attention to because this problem is super important. Because now I need to solve 2 different triangles. So what we do, rather than naming this B as well, we call it B prime. That little dash above, we use the word prime. And this C is no longer the actual, it's not the same C, and that's kind of obvious. This is a big angle, that's a small angle. So this is C prime. And this little side down here is little c prime. So what you have to solve for is, for the first triangle, you have to solve for big B, big C, and little c. And for the second triangle, you need to solve for B prime, C prime, and little c prime. Now, for this triangle, for the first triangle, just use the law of sines as normal. Okay, so I'm going to go ahead and do that for this particular problem. So for this first triangle, I have the sine of 30 over 7 is equal to the sine of big B over 7. I drew that wrongly there. Sine of 30 over 6, by the way. I solve for big B. So big B, and this is solving that you guys should be able to do by now, is the sine inverse of 7 sine 30 over 6. And if I did that really quickly, make sure my mode's in degrees. I go sine inverse of 7 sine 30 divided by 6. And I get 35.69. All right, so I do that. I am solving this one fully because you guys need to know how to do this. And to find the third angle, I just subtract from 180. So 180 minus 30 minus that angle I just found, I get 114.31. And then to find little c, I say c over the sine of big C, I'm going to use my answer button on my calculator, is equal to 6 over the sine of 30, which means C is 6 sine of big C over sine 30. Remember, use your answer key there, answer button. I get 10.94. Now, none of these three numbers go into your second triangle. None of them. But we're going to use one of them to find the other ones. Now, on this second triangle, I'm going to have to delete some stuff here. Kind of wish I had a big delete button. Now, what I want to think about is some geometry that we might remember. Now, as you recall, this is the other triangle, right? This is this triangle over here, where this side was a 6. Well, if this side is 6 and this side is 6, that means it's what's called an isosceles triangle. That means this side is equal to this side. But that gives me something else as well. That tells me that this angle is equal to this angle. And that means if I know what this angle is here, I can find this angle by doing 180 minus. So that means that B prime is equal to 180 minus whatever my B angle was. That's super nice because that does not require the law of sines at all. So I can do 180 minus B. So I'm going to go back up into my calculator, find that number I had, and I get 144.31. So that means I found this angle here. And now to find the third angle, notice I haven't even used law of sines yet for the second triangle. I will, but I didn't need to yet. I get 180 minus that number, that 144.31, minus the 30 that I already had. And I get an angle of 5.69. And it's okay to have small numbers like this, by the way. Now I need to use the law of sines. So if I eliminate the rest of this picture that wasn't actually there, and kind of figure out, oh, finding C prime. So C prime over the sine of C big C prime is equal to, let's go 6 over the sine of 30. I'm trying to use as many of the numbers that were already given to me, by the way. So C prime is equal to 6 sine big C prime over sine of 30. And voila, I get C is equal to 1.19 units, whatever the length is. And there we have now actually solved for both triangles. Is it a lot of work? Yes. Do they all come out with two triangles? No. This is where you have to determine if it's one triangle or two triangles or zero triangles, and that's why I gave you that table to begin with. So lastly, I have one more example here, and it's this one where A is 2, B is 7, and angle A is 36. So if I was to draw this triangle, let's just say I called this B, and this now is little b, and let's call this little a. Let's just say that's what was given to you. That way you can't say, Mister, you never gave me that example. Okay, so here now, the angle given is the one that I'm going to put there. That's 36. Its side is 2, and the connecting side is 7. That means this is big A, and this is big C with little c. And I need to figure some stuff out, so let's figure out the height. The height is given by B sine A, but I don't have a big angle A, but it's this angle and its connecting side. So it's just 7 times the sine of 36. And doing the math on that really quick is 4.11. Now this is an acute angle. So I go to my acute angle section and I first look at myself, I ask myself, is A less than H? But it's actually not A in this case, it's the opposite side, right? It's the one that's connected, or not connected, but it's the same as the angle. So it's not A in this case. I want to know is actually B less than H here. And B is 2, which is less than 4.11, and that's the one everybody likes because there are no triangles possible. And that actually means I didn't need to draw this triangle, technically, but I used it to show the height and the other piece. All right, so that's all the farther you need to go because I can't solve a triangle that doesn't exist. And what this means is this side length is 2, and any way I swing it, it will never reach the bottom. So that's a 2 there. And that's all the farther it would go. So there's no triangle that I can draw, given this 36-degree angle and this length of 7. All right, so here's your assignment. All the problems on here are SSA versions, and some of them may end up with 2 triangles, some of them may end up with 0 triangles, and some of them will end up with 1 triangle. Again, that's for you to make the determination. All right, have a good evening. I will see you guys tomorrow.